When dealing with separate electrical feeds to structures like a house and garage, proper grounding and bonding are crucial for safety and code compliance. It's essential to understand the correct procedures for installing grounding rods, bonding neutral and ground wires, and wiring configurations for different electrical panels. One grounding rod should be installed for each structure, meaning one for the house and another for the garage. These grounding rods must be bonded together using a number 6 American wire gauge copper bare wire. This connection creates a common ground potential between the two structures, which is important for safety. The neutral and ground wires should be bonded together at the main service panel for the house and at the transfer switch for the garage. This is a critical step in establishing a proper grounding system. Additionally, the neutral and ground wires should be bonded together at each subpanel in both the house and the garage. This ensures that all electrical panels have a proper ground reference. The 200 amp dedicated feed for the house must have 4 wires, 2 hots, 1 neutral, and 1 ground. This 4-wire configuration is essential for providing a dedicated and safe electrical supply to the house. The 200 amp feed for the garage and transfer switch can have 3 wires, 2 hots, and 1 ground. However, depending on local codes and specific requirements, it may be preferable to run a 4-wire feed to the garage as well. The 80 amp subpanel in the house should be fed from the generator panel with 4 wires, 2 hots, 1 neutral, and 1 ground. This 4-wire configuration is important for ensuring proper operation of the subpanel and for safety. At the main service panel for the house, bond the neutral and ground wires together. This is the primary bonding point for the house's electrical system. Do not bond the neutral and ground wires from the generator panel at the main service panel for the house. The generator panel has its own separate bonding requirements. At the transfer switch for the garage, bond the neutral and ground wires together. This is the primary bonding point for the garage's electrical system. Do not bond the neutral and ground wires from the house at the transfer switch for the garage. The house and garage electrical systems are kept separate in terms of bonding. Bone lines and polyvinyl chloride water feeds can be run in the same trench as the electrical wiring, but they should be separated by at least 12 inches. This separation helps to prevent interference and potential hazards. All wires should be properly sized and protected according to the National Electrical Code or NEC. This is essential for ensuring the safety and reliability of the electrical system. It is highly recommended to consult a qualified electrician for professional installation and verification of the electrical system. Electricians have the knowledge and experience to ensure that the installation meets all applicable codes and safety standards. When working with electrical systems, safety should always be the top priority. It's crucial to follow all applicable codes and regulations and to take necessary precautions to prevent electrical shock and other hazards. It's important to understand the difference between grounding and bonding. Grounding provides a path for fault current to flow back to the source, while bonding ensures that all metallic parts of the electrical system are at the same potential. Both grounding and bonding are essential for electrical safety. Grounding involves connecting the electrical system to the earth through a grounding electrode, such as a grounding rod. This connection provides a low impedance path for fault current to flow back to the source, which helps to trip circuit breakers and prevent electrical shock. Bonding involves connecting all metallic parts of the electrical system together, such as metal conduits, enclosures, and equipment. This ensures that all metallic parts are at the same potential, which reduces the risk of electrical shock. When installing grounding electrodes, it's important to drive them deep enough into the earth to ensure good contact with the soil. The depth required will vary depending on local soil conditions, but generally, grounding rods should be driven at least 8 feet into the ground. It's also important to ensure that the grounding rods are properly connected to the electrical system. This can be done using grounding clamps and conductors that are sized according to the National Electrical Code. When bonding metallic parts of the electrical system, it's important to use bonding jumpers that are sized according to the National Electrical Code. Bonding jumpers should be installed at all points where metallic parts are connected together, such as at conduit couplings and equipment enclosures. It's also important to ensure that the bonding jumpers are properly tightened to provide a good electrical connection. In addition to grounding and bonding, it's also important to use proper wiring methods and materials. All wiring should be sized according to the National Electrical Code and should be protected from physical damage. It's also important to use the correct type of wire for the application, such as copper or aluminum wire. When installing wiring, it's important to follow all applicable codes and regulations. This includes using proper conduit and fittings, as well as ensuring that all connections are properly made. It's also important to protect wiring from physical damage, such as from nails, screws, and other objects. When working with electrical systems, it's important to always disconnect power before starting any work. This can be done by turning off the circuit breaker that supplies power to the circuit being worked on. It's also important to test the circuit to ensure that it is energized before starting any work. When testing a circuit, it's important to use a voltage tester that is rated for the voltage being tested. The voltage tester should be used to verify that the circuit is energized before starting any work. It's also important to wear appropriate personal protective equipment when working with electrical systems. This includes wearing safety glasses, gloves, and other protective gear. It's also important to be aware of the potential hazards of working with electricity, such as electrical shock and arc flash. Arc flash is a dangerous condition that can occur when there is a short circuit in an electrical system. Arc flash can cause severe burns and other injuries. To prevent arc flash, it's important to follow all applicable safety procedures and to use appropriate personal protective equipment. It's also important to have a qualified electrician perform a hazard assessment before starting any work on an electrical system. The hazard assessment will identify potential arc flash hazards and will recommend appropriate safety procedures. When working with electrical systems, it's important to be aware of the potential for electrical shock. Electrical shock can occur when a person comes into contact with an energized circuit. Electrical shock can cause serious injury or death. To prevent electrical shock, it's important to follow all applicable safety procedures and to use appropriate personal protective equipment. It's also important to be aware of the potential for static electricity. Static electricity can build up on a person's body and can discharge when the person touches a grounded object. Static electricity can damage sensitive electronic components. To prevent static electricity, it's important to wear anti-static clothing and to use anti-static mats. It's also important to ground yourself before touching any sensitive electronic components. When working with electrical systems, it's important to be aware of the potential for fire. Electrical fires can occur when there is a short circuit or overload in an electrical system. Electrical fires can spread quickly and can cause significant damage. To prevent electrical fires, it's important to follow all applicable safety procedures and to use appropriate fire extinguishers. It's also important to have a qualified electrician inspect the electrical system regularly to identify potential fire hazards. When working with electrical systems, it's important to be aware of the potential for explosions. Explosions can occur when flammable gases or liquids are present in an electrical system. Explosions can cause serious injury or death. To prevent explosions, it's important to follow all applicable safety procedures and to use appropriate explosion-proof equipment. It's also important to have a qualified electrician inspect the electrical system regularly to identify potential explosion hazards. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. The NEC is published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years. The NEC is widely used in the United States and other countries. The NEC covers a wide range of electrical topics, including grounding, bonding, wiring methods, and equipment installation. The NEC is a complex document, and it's important to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the NEC. Some of the key requirements of the NEC include proper grounding and bonding, proper wiring methods, and proper equipment installation. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to flow back to the source, while bonding ensures that all metallic parts of the electrical system are at the same potential. Proper wiring methods are essential for preventing electrical fires and other hazards. Wiring should be sized according to the National Electrical Code and should be protected from physical damage. Proper equipment installation is essential for ensuring that electrical equipment operates safely and reliably. Equipment should be installed in accordance with the manufacturer's instructions and should be inspected regularly to identify potential problems. In addition to the NEC, there are other codes and standards that may apply to electrical work. These codes and standards may be adopted by state and local governments. It's important to check with the local authorities to determine which codes and standards apply to electrical work in a particular area. When performing electrical work, it's important to obtain the necessary permits. Permits are required for most electrical work, including new installations, alterations, and repairs. Permits are issued by local building departments. Obtaining a permit ensures that the electrical work will be inspected by a qualified inspector. The inspector will verify that the electrical work is performed in accordance with the applicable codes and standards. When hiring an electrician, it's important to choose a qualified electrician. A qualified electrician will have the necessary training and experience to perform electrical work safely and reliably. A qualified electrician will also be licensed and insured. It's important to check the electrician's license and insurance before hiring them. When obtaining electrical supplies, it's important to purchase high-quality supplies. High-quality electrical supplies will be more durable and reliable than low-quality supplies. High-quality electrical supplies will also be safer to use. It's important to purchase electrical supplies from a reputable supplier. A reputable supplier will sell only high-quality electrical supplies. When installing electrical equipment, it's important to follow the manufacturer's instructions. The manufacturer's instructions will provide detailed information about how to install the equipment safely and reliably. It's important to read the manufacturer's instructions carefully before starting the installation. When troubleshooting electrical problems, it's important to follow a systematic approach. A systematic approach will help to identify the cause of the problem and to find a solution. The first step in troubleshooting an electrical problem is to gather information. This includes asking questions about the problem and observing the symptoms. The next step is to develop a hypothesis about the cause of the problem. The hypothesis should be based on the information gathered in the first step. The next step is to test the hypothesis. This can be done by performing tests on the electrical system. The final step is to implement a solution based on the results of the testing. If the problem is still not resolved, it may be necessary to consult with a qualified electrician. Always remember, electrical safety is paramount.